Good morning, afternoon, or evening, wherever you are in the world. Welcome to Skyway's live webinar, Vertiport Simulation, See How They'll Really Work. My name is Beau Cassidy. I'm with Business Development at Skyway. To give you a little rundown of what Skyway is a provider of services for UAM that issues low-altitude airspace authorization. Our system enables UTM, eVTOL, and UA operations to share airspace intelligence with ground operations such as vertiports and air traffic control agencies. Skyway integrates various airspace services into one cohesive infrastructure solution, one that provides real-time dynamic flight planning for piloted and autonomous aircraft. At Skyway, we do a great deal of internal research on a variety of topics with our experts and our partners. And one topic specifically that we have been deeply involved in is in the vertiport space. It's important for us to have insight into every vertical in the industry so we can build the most comprehensive infrastructure possible. Our primary goal is to help build our ecosystem to allow UAM to grow extensively. We will be having a Q&A after the presentation. However, you are more than welcome to submit your questions at any time. Please feel free to offer any suggestions about the simulation. However, those will not be read aloud. And now I have the pleasure of introducing Senior Vertiport Integrator / Planner, Ken Reed. Take it away, Ken.
Thank you, Beau. Welcome, everybody, for coming out today and attending this webinar. As you can see on the screen, I'm not going to read it to you. I've been an airport planner for 30 years, and I specialize in computer simulations of airports. Earlier last year, I was looking around and sorry, guys. So earlier last year, I decided to see if we could apply these simulation techniques that we use at larger airports to vertiports. And I quickly found that that no one else, I think, had done a simulation of a vertiport. So I started that process. At the beginning, I thought there might be too many things that I might need more information. But I think we've come to some interesting conclusions, and you'll see that today. Just to run down on the agenda, we're going to talk about what we've assumed in the simulation, what we know, what we don't know. And at the very end, we'll talk about what conclusions we were able to draw, even though these results are preliminary. So why is this important now? These aircraft aren't flying yet. Why do we need to be doing simulations of vertiports? Well, vertical takeoff and landing and short takeoff and landing aircraft are expected to be certified in the next several years, easily within the planning range of a typical master plan. And airports and communities need to develop this infrastructure now to plan for all of the different facilities that we need: charging, communications, airfields, the vertiports, how many FATOs do we need, vehicle parking, etc. Also, appropriate planning will help us to maintain safe separation from existing legacy traffic. We know these aircraft are going to show up at your airports if you're operating an airport, and we want to make sure that we plan for that appropriately. We also want to be able to protect the future development for expansion of the vertiport, including the airspace and the land use nearby. And communities are going to be competing for these type of operations. Operators will distribute vehicles and resources to the markets that have developed their infrastructure first and more fully. So now is the time to build this infrastructure or plan for this infrastructure so that your community can participate in this new economy. Finally, simulation is needed to demonstrate the viability of these types of layouts, procedural issues, the capacity of the vertiport, and any expected delays. Standards and best practices just don't exist yet, so today's efforts will become the blueprint for future development. So what do we know and expect? Well, we know that the advisory circular for vertiports will have a draft version out in the next few months, and they expect the final version to be published within 2 years. From what we know about the draft version is it'll be very similar to the advisory circular, the existing advisory circular for heliports for transport category, which is chapter 3 of that advisory circular. Now, can we just use all of the heliports around the country, make them vertiports and move on? Not very easily. The heliports today are typically designed for emergency use at hospitals or emergency use on top of tall buildings. Executive use, they're not very accessible, and they're not designed for high volume public use. New vertiports and infrastructure will be needed to allow this industry to develop. We know that aircraft will be certified and operating again within the planning duration of a master plan. The advisory circular that I just mentioned for heliports, transport category, identify what you need at a heliport, or now vertiport, and those are listed here. There is a takeoff and landing area, which is a minimum of 50 by 50 feet, and I've used the minimums from the advisory circular for the simulation today. We also know that we need clear approach and departure paths, although those aren't shown here on this exhibit. We need a clear area for ground maneuvers and a safety area and a FATO. The dimensions of those are here. Let me point out that mobile objects within the FATO are closed to other aircraft. The TLOF and the FATO are closed to other aircraft if a helicopter or any moving object is within the FATO or the safety area. An approach and departure surface is centered on each approach and departure path. So every vertiport definitely has an approach direction and a departure direction. It can switch. It's not always 180 degrees. Sometimes it could be as little as 135 degrees. So if you have unique wind characteristics, for example, then those approach and departure paths can be slightly misaligned, and they can curve. Let me point out actual dimensions may vary based on the critical aircraft at a specific vertiport. Now, you may have more than one FATO operating side by side. What is the separation standard? Well, again, we don't know what the final vertiport advisory circular will say, but we do know regarding helicopters that if the heliport operator intends for the facility to support simultaneous operations, then you must provide a minimum of 200-foot separation between the FATOs. However, and the FATOs themselves are 100 feet wide, so that gives you a total separation of 300 feet centerline to centerline. There is a second document within the FAA, however, for air traffic control that does allow helicopter operations as close as 200 feet. But we don't. I don't know for a fact, but I don't expect that that will be the standard, and that's not the standard that I modeled. So we've used the 300-foot separation between FATOs. Now, how did I do this? I used a program called AirTop, developed by a company called Transoft, and you can go and visit their website at transoftsolutions.com to learn more about AirTop and how it's being used. I've developed an unconstrained forecast here, meaning I've just pumped as much traffic into this vertiport as possible so that I can measure the capacity of the vertiport. Now, let me also add that parking is assumed to be available. If you have a vertiport that has only 3 parking spots and those 3 parking spots are full, then your vertiport is essentially closed. Well, in my simulation, I made sure there was plenty of parking, and you'll see later on that that becomes kind of a critical issue. I've estimated the arrival flow rates to get aircraft in as quickly as possible. And the departures can either go on a separate FATO, which you'll see in the simulation, or can depart between the arrivals. We'll talk about that more as well when we talk about the actual numbers. Speeds were derived from existing helicopter operations. So we're assuming that the descent rates and climb rates, acceleration and deceleration, are similar to existing helicopter operations. Time to land and clear the FATO was also estimated using typical taxi speeds. But these aircraft come in, they land, so they're starting their taxi from a dead stop. Some of them have transition periods, and we'll talk about that too. Finally, the vehicle parking spot, or the gate, what we would call a gate at a regular airport, are generous in my simulation to allow for adequate taxiing, growth, pedestrian traffic near hover taxiing aircraft, etc. Actual dimensions may differ based on advancements in operational characteristics, aircraft performance, and aircraft towing technologies. And again, all results are preliminary, but we'll discuss the assumptions and how we came to those results. Now, there's a lot of things we don't know yet about aircraft performance. We need the OEMs to tell us how fast will these flights be going. In examples of vehicles that transition from horizontal flight to vertical flight, how long does that transition take? In the case of Joby's aircraft, for example, where the engines literally rotate upward, how fast is the aircraft going before it starts that process? How fast is it going when it's done with that process? And what distance does it cover during that process? Fleet mix and schedule. Again, I've just done an unconstrained demand, but if I was modeling an actual vertiport, we would develop forecasts of demand. We would create a schedule. That schedule might include different types of aircraft that would make up the fleet mix. And the schedule would change throughout the day. So we would have peak hours, peak times. You might have peak days, etc. Critical aircraft size, weight, and dimensions, as we saw in the definition of the Vertiport Advisory Circular, Heliport Advisory Circular. The critical aircraft at a vertiport determines some of the dimensions. So again, if we were modeling a specific vertiport, we would know what that critical aircraft size was. Finally, eVTOL and eSTOL. We'll talk about how you could combine two FATOs to make a single short takeoff and landing runway. And there's a little article quote here about how developers of short takeoff and landing aircraft, including Electra and Airflow, claim that their aircraft can land with as little as 100 feet of ground roll on a 300-foot balanced field length. These figures would seem to make them compatible with many of the vertiports being planned today, and there's a source there as well. A little bit more of what we don't know. We don't know what the approach procedures will be like. We don't know what the final airfield or passenger capacity will be of these vehicles. And we don't know about the demand fluctuations. You know, will they be seasonal? Will there be weekly fluctuations, daily fluctuations? As you can imagine, if the vertiport is downtown and is carrying a lot of commuter type activity, then they will have a lot of arrivals in the morning and departures in the evening, that sort of thing. But for what I've modeled so far, I've used 50% arrivals and 50% departures. So how do we design vertiports of the future? Here's just a couple of graphics. If you go to your computer and you Google vertiport and look at the images, you'll see dozens of vertiport layouts that all seem to be completely different. And the Vertiport Advisory Circular will support some of those designs, and some of them will obviously have to change. Now let's start small and talk about the simplest vertiport possible. In my community, we have a couple of tennis courts side by side. I never play tennis, but you could tear out those two tennis courts and have roughly enough space to put in a FATO for a very small, very simple vertiport. Wouldn't have a terminal building, may or may not have charging, but basically it would be a point at which I could call up a flight, he would land, I'd get in, and we'd take off. The simplest possible activity. I've listed here on this screen all of the activities that will happen when an aircraft uses a vertiport like this that has no additional parking. So everything that's being done on that list is being done within the FATO. And so while that aircraft is there, no other aircraft can use that FATO. That vertiport is essentially closed. And I come up with a total of 12 minutes. And that doesn't even include waiting for passengers. So if a vehicle showed up early and their passengers aren't ready to go yet and he's waiting, then that would add to this time as well. Just to talk briefly about recharging. We don't know yet what the statistics will be, what the charging times will be. But if we assume that an average recharge time will be 30 minutes, and we assume that the average number of vehicles that need recharge is only 50%, and again, that may change. In the morning, it might be very little, and in the evening, it might be everybody. But if we use those two assumptions, then we get an average recharge delay of 15 minutes. Added to the time already spent, the 12 minutes, giving us a total turnaround time anywhere from 12 minutes, the minimum, to 27 minutes, the maximum. Again, that's not the maximum, that's the minimum plus the average for charging. It may be much higher. So what kind of capacity does that give us? Well, if it's the minimum, if the turnaround time is the minimum 12 minutes, then you could get 5 operations per hour, 5 arrival operations per hour. But if it's 27 minutes, then you only get 2. So that vertiport is closed, or not closed, but is only operating with 2 operations per hour. I've used a simple planning assumption of 3 passengers per aircraft. So you can see on there as well that the number of passengers that flow through that vertiport is limited to between 6 and 15 people in an hour. Now, if we simply add parking off of the FATO, then that same slide before where I listed the items that have to be done while on the FATO, now I've broken them up to operations that have to be done on the FATO and some that can be done off of the FATO. So what does that give me? It gives me a total of 3 minutes of activities per arrival flight that occupies the FATO. So, and then another 10 minutes for features or functions that will happen off of the FATO. So now the capacity, because I'm only occupying the FATO for 3 minutes, the capacity goes up drastically. We still have the recharge time, but the capacity goes from, what did we say in the last slide? 2 to 5. Now we're looking at 20 arrivals per minute. 60 minutes in an hour, 3 minutes per operation. That's 20 operations. So the passengers per hour per FATO is 60. Take that 20, multiply it times 3, and we get 60. So the minimum gates that we need, because the turnaround time is nearly half an hour, each flight occupies a gate for half an hour, or one flight equals 1/2 gate hour. Before we go on to the video, let me just, on the left side, again, show how we calculated that. So we have a load and unload and prep time of 15 minutes, charging another 15-minute penalty for an average turnaround time of 30 minutes. So therefore, we get 10, we need 10 gates to occupy that. So this is what it looks like if you model this. Again, one single FATO. I have yellow trajectory lines showing aircraft arriving and blue trajectory lines showing aircraft departing. This is operating at 10 times normal speed, but you can quickly see what this looks like. Here comes another arrival. Okay. Thank you, Beau. Just a little bit more about the 3-minute separations between arrivals. Why do we need 3 minutes? Well, there's going to be en route separation. These aircraft are going to be separated as they're flying at higher speeds, and then they're going to compress together as they slow down. They slow down so much that that compression is pretty great. So we're not sure what that en route separation will be yet, but we think that there will be a significant amount of separation. Arrival scheduling to avoid hovering and delay. These vehicles, just like helicopters, are least efficient when they're hovering, and they burn up the most battery life and power. So we want to avoid that. So we think that because many of these flights, these air taxi type flights, will occur in a community, and those flights will typically be 20 minutes or less, that we will be able to schedule the flights in a way that a VTOL aircraft will not depart from its departure vertiport until it has an arrival time scheduled at the destination vertiport. And we have to give that a little bit of time, a 3-minute window perhaps, to make sure that we schedule that properly. Similarly, time to clear the FATO in the safety area. Again, we're using standard taxi times, but these aircraft are taxiing from a dead stop, so they take a little bit more time than an airplane might at a regular airport. At a regular airport, he'd land at 130, he'd exit on a high-speed taxiway, so he'd clear the runway very quickly. But these vehicles are going to literally stop. Some of them are going to transition from vertical flight to horizontal flight before they begin taxiing off the FATO. Also, there might be potential delays on the taxiway. So there might be a flight that can't leave the taxiway because it can't leave the FATO because there's another aircraft passing by on the taxiway. Again, actual results may vary significantly based on aircraft type and other factors. So let's talk about multiple FATOs. Sometimes you're going to need more than one FATO for operational reasons. Here, before we talk about putting them side by side, let's talk about this where I've separated them so that arrivals come in on one FATO, then the aircraft taxis to the parking position and then taxis and departs from a separate FATO. Now, these two FATOs, one in front of the other, simultaneous arrivals will not be allowed because the arrival paths overlap. You wouldn't want to be arriving to the second one as an aircraft was departing from the first one. Despite adequate safety separation, simultaneous operations will not be possible. Hourly capacity might be higher than with a single FATO, but much less than twice as high, and it would require additional coordination in order to make those operations work. But the separation benefit, the safety benefit of separating these FATOs is great. By separating the FATOs, the risk of a departure occurring beneath an arrival is avoided. So imagine the worst possible scenario would be you were flying into a FATO and you're going to hover down and land. And if someone is unaware of that operation and they depart on that FATO, then they enter the FATO at a time when you can't see them below you, and then they take off beneath you. That would be very bad. Similarly, by putting in the safety margins, we're able to put in taxiways between these FATOs, so no aircraft is ever taxiing beneath either an arrival path or a departure path. So these aircraft arrive, then they taxi off the FATOs. They can go back and forth, left and right. And then when they depart on the other side of the vertiport. Multi-FATO short takeoff and runway. So if I combine those two FATOs that I just showed you a moment ago, then we have enough length for a short takeoff and landing runway between these two FATOs. This gives you an equitable layout for both VTOL and short takeoff and landing, or STOL, operations. But obviously, you're going to put FATOs side by side so that you can maximize your capacity. And I've done 5 side by side. So I have 5 arrival FATOs, 5 departure FATOs. So I have a total of 10. Again, we've improved safety. We're never taxiing beneath an arrival, approach, or departure path. We have dedicated arrival and departure paths, and nobody is departing on the arrival path. Beau, if you'll play this video, we'll show you what this looks like. So here we are looking down off of the first departure path. This first aircraft is going to come right at us, and then he's going to turn slightly and depart. While you can see the parking is being filled up by arrivals from the other FATOs. Aircraft coming in and landing turn either left or right, depending on which parking area they're going to keep the shortest distance. Similarly, aircraft that are departing to leave, like this one on the right side, is going to taxi over to this FATO, and he's going to depart right in front of us. He will pick the FATO that is closest to his parking position to allow him to minimize taxiing times. And thank you, Beau. So how big is this vertiport? So as you can see here, we've laid out 10 FATOs, again, 5 arrivals and 5 departures, with enough safety area between them to put in parallel taxiways. And this area is 1,600 feet wide and 720 feet deep. And you can see the dimensions that we used. Now, not everybody can understand what that means, so let's compare that to other things that we do know. And let's start with, if you were in Minnesota, you might go to the Mall of America, which is the largest mall in America. And there are 2 large parking garages on either side, the east and west side. What I've done here is I've taken an outline of those 10 FATOs, and I've laid it on top of the east parking garage at Mall of America. This one is important because the light rail system that serves the community, that station is right beneath the mall underneath this parking structure. Similarly, you can see if you didn't want to put them on top of the mall, there's plenty of room for 3, maybe even 6 FATOs on the surface parking lot that's just due east of the airport. This is what it looks like with the 2 FATOs on the right, but it's the same parking garage. Now, if you were in Orlando and you went to City Hall, that's the building with the round circle on top of it, you can see that there is a parking garage right next to that building that has enough room for a single FATO. But many of you might be operating airports. So what is this going to look like relative to a major airport? So the large yellow rectangles are all the area needed for all 10 FATOs. The small yellow rectangles are if you only wanted 1 FATO. This airport happens to be Orlando. So you can see that there's roughly enough space on top of the terminal building or on top of the landside parking garage next to the terminal building, or maybe out by the rental car areas, or even airside between 2 of the remote terminals. This chart shows how much space will be taken up by any one of these layouts. So remember, we talked about 1 FATO gives us the capacity for 20 operations per hour. 2 FATOs, 40, 3 FATOs, 60, 4 is 80, 5 is 100 as we go up. Now, in the first box in the lower left-hand corner, the blue dots indicate the number of parking spaces available. Remember, I said if you had 3 parking spots and they were full, then your vertiport is closed because you wouldn't be able to park because you wouldn't be able to land because you wouldn't be able to park your vehicle. So as we go up and add more parking spaces, we obviously take up more space. But then that line flatlines. What does that mean? That means that I could add more parking, but I wouldn't be able to add any more capacity. Once I hit that line, I've reached the capacity for the FATO. So this is why parking is so critical. You want a balanced airfield and parking. You would not want to not be able to use your airfield because your parking was full, and you don't want to build too much parking. Although, certainly you could use extra spaces for overnight parking and other things. So that's what we're showing here, the blue dots and the orange dots. Orange dots are 2 FATOs, but they're lined up vertically, so they don't give you any additional capacity. Then we come over here to the gray dots, 2 FATOs side by side, or orange dots, 2 FATOs plus 2 more FATOs for departures. And now we've separated those arrival and departure FATOs. As we move to the right, it takes up more space, et cetera, et cetera. So you can see how much space is going to be taken up for just the airfield, just the FATOs and the aircraft parking when you get to 5 FATOs and 100 parking spots. I'm not sure if that was out of order. I guess not. So what we're looking at here is a Joby type aircraft using a simple rendering program. If you look at the vehicle, you'll see that the engines have pivoted vertically as it comes in. It's slowed down as it came down the approach. It's going to land. As soon as it lands, those engines are going to pivot forward again. 4 of the 6 engines are going to shut down. It's going to taxi off of the FATO using the remaining 2 engines. It would normally go to parking or unloading passengers. But in this case, I'm just going to have it turn and taxi to the next FATO to depart again. So he's going to turn. He's going to wait at a stop bar, start up his other engines. When he's ready to go, he's going to take over the FATO. Those engines are going to pivot up to the vertical. He's going to lift up and take off and be on his way. We can easily add 3-dimensional buildings. We can pull this data off of the internet, and that's what you're seeing here in the upper left-hand corner. If we put 2 FATOs on top of the convention center in downtown Tampa, coming in over the water, that's what that would look like. I threw 1 FATO on top of just sort of a random tall building in downtown Chicago. That's the upper right-hand corner. You can see the parks and the lake to the right. And down on the bottom, the Houston Convention Center, I've put in a short takeoff and landing runway. I'm unaware that I had done that before. But at the moment, you're going to see this aircraft come in and land. So you get a feel for how big this vertiport is based on the buildings around it. Now, this model is scalable, so I can easily model more FATOs or fewer FATOs. I can model actual fleet mixes once I have them by putting in a flight schedule. I can revise the model when OEMs issue performance characteristics for their aircraft. And we have flight schedules. I can model at grade or elevated parking spots, the difference being that at grade, we might have access to more parking. So if we fill up our parking, maybe we can taxi some of these aircraft to a remote parking spot. But if you're elevated, what you got is what you got. Now, if the average turnaround time is 30 minutes instead of 30, which is what I modeled, then the number of gates per FATO will double. So remember, we were showing 10 parking spots for 1 FATO, 20 operations. Each turnaround is half an hour, so you need 10. So again, if instead of 30-minute, if they were there for an average of an hour, then you need to double the amount of parking that you have. Also, if the arrival rate is 2 minutes instead of 3, so maybe we can get the separation down, get these operations moving faster. Maybe we go from 3 minutes down to 2. Again, your arrival capacity per FATO goes up from 20 to 30, and your parking requirements will also go up. If and when all the parking positions are full, then the vertiport is essentially closed to arriving aircraft. So we've envisioned a regional, what we're calling Vertipark, which may be a logical parking, storage, charging, and maintenance operation. So this would be a vertiport not meant for passengers, but just meant for parking vehicles, charging them, and then releasing them back out into the system. Local existing airports, smaller general aviation airports, may be optimal choices for a vertipark. Empty vehicles cannot be forced to depart, but appropriate fees and policies can be implemented to encourage them to depart. Again, this is a method for minimizing the amount of parking that you need at your vertiport. And finally, the model shows taxiing delays. I haven't shown them in this. It's not particularly pertinent, but airspace delays could also be modeled at a specific site. Once we know the schedule between vertiports, we can calculate the airspace delay. How long are people delayed, either waiting to depart or if they get delayed along the way. Here's a tweet that Joby Aviation sent out. I show this as an example of what is the industry thinking is possible. And the critical line here is that just a dozen optimally placed skyports can serve well over 10,000 trips per day. So what does that mean? Well, if we distributed those 10,000 trips per day evenly across those 12 vertiports, each trip being 2 operations, so 20,000 daily operations, these are the results that we would get. We would need to serve 1,666 daily operations at each of the 12 vertiports. We would end up requiring 52 hourly arrivals, and that would require 3 FATOs. Remember, 2 would only do 40. So 3 FATOs, and we would require at least 30 parking spots at each of those 12 FATOs. Now, that was assuming even distribution. Of course, nothing's ever even in life. There's in an uneven distribution, it'd be more like 80% of the total operations would probably occur at maybe 50% of those vertiports, maybe even less. If that were the case, then now we have vertiports, the peak vertiports, that would require 2,666 daily operations, 166 hourly, and 86 hourly arrivals, which would require 4 arrival FATOs and at least 40 parking spots. That's a lot of parking. Now, how many vehicles would that require? Well, if each aircraft flies an average of a 30-minute trip, which I think is tight, including the turnaround and charging, and they did that for 16-hour days, 32 trips per day per aircraft, or 64 operations per day per aircraft, that would require 156 aircraft in order to achieve the 10,000 trips. So again, if you remember back to any image you've ever seen of a vertiport, I doubt you've ever seen an image of a vertiport with 156 aircraft parked at it. So we need to keep this in mind. Again, 5 arrival FATOs per vertiport can generate 100 arrivals per hour, 1,600 arrivals per day, 3,200 total operations per day. So what can we conclude? Even though these are preliminary, this is a preliminary analysis, what can we conclude? Well, we can conclude that we need more information. OEMs need to provide more performance characteristics for their vehicles. And that vehicle parking is a seemingly overlooked infrastructure need. To minimize parking requirements at the vertiports, a vertipark may provide needed infrastructure in a centralized area, perhaps in an industrial area, so you're not worried about community noise issues. Think of this as the same way you might have a light rail system that has a train station where the trains stay overnight. You would need something like that if we get into systems, communities with this many operations. Thank you for your time. I'm going to hand it back over to Beau.
Thank you, Ken. Fantastic work. Thank you so much. Outside of our core products and services around traffic management, we do offer a variety of services. So if you are in the planning phase of building a vertiport or even considering building a vertiport, please do not hesitate to reach out to Ken for assistance. His contact is on the slide below. Skyway offers experienced industry professionals to help you plan your investment into the future of eVTOL infrastructure. So, UAM vertiport planning and simulation, as you saw today, technical expertise, so policy, regulatory consulting, DOT, FAA liaisoning. We also offer vertiport zoning and ATM certification, working on, planning on building your vertiport in a local municipality, what those cities are going to have to do in order to plan for the industry and create new regulations to fit accordingly. Resource allocation and assignment, and vertiport aircraft equipment integration. So if you have a vehicle that you're looking to integrate into a local vertiport, we can offer some guidance there. Our next vertiport webinar, so webinars pertaining specifically to vertiports, will include vertiport operations and capacity. So how it's really going to pan out when people arrive, and how many different types of aircraft are going to be there. We'll address the issues of wheels versus skids. Ken touched on some of that, the time it's going to take based on the type of aircraft and landing gear, charging systems and layout uses, how the vehicles are going to charge, how long they're going to take to charge, demand versus capacity. So, Ken's simulation outlined unlimited demand. So what happens when there are different variables of demand involved? Terminals versus FATOs. And as Ken alluded to, the Vertiport Simulation. So a new type of vertiport for storage. Please follow us on social media. As mentioned on this slide, when searching LinkedIn, make sure to click on the page with our logo, because if you click on another Skyway, something else is gonna come up if you just type in Skyway and click enter. So make sure it's our logo. You can submit your email to be added to our mailing list by going to our website at goskyway.com. This will give you all updated information on future events and webinars on a variety of topics that we are addressing. We are going to be doing different webinars outside of the vertiport space, so there's going to be a lot more involved there. So now we will begin the Q&A portion of our presentation. If you have not submitted your questions already, please do so now. I'm going to give you guys a few seconds to hand these in. I know we had a couple that came in here. So Ken, are you ready to answer a few of these?
Always.
Beautiful. Okay, first one comes in regarding size of the parking. In your simulation, you show a large size for parking. Is it a good assumption that the size of parking area can change? Do you want to detail that again, just very quickly?
The question is, can the parking requirement change?
That's what it says here.
Okay. Yeah, certainly. Some vehicles, some vertiports may operate very efficiently and not require as much parking as others because passengers will always be ready to go, for example. But we do know that different vehicles are going to require different charging times. So that will change the number of parking spots that you need. It's possible you might have a vertiport that has a critical aircraft that is larger than others. So you might have a vertiport that has some parking spots that are dedicated to larger size aircraft and some that are smaller. You might have some parking spots typically that a parking spot will either be loading and unloading passengers, or you might be using a parking spot just for charging your vehicle, or you might be simply storing your vehicle, in which case that parking spot might be much smaller. Maybe they can stack them closer together, like cars in a rental car lot, for example. So absolutely, there's plenty of potential for different size parking requirements.
Okay, next question. Why have you chosen to focus on the transport category heliports?
I didn't choose to focus on it. It just happens to be what the standard is that the advisory circular is headed towards. And transport category has additional safety features than private or heliports at hospitals, things like that.
Great. And another question here. I think it'd be good to reiterate this. What software did you say you used for this simulation?
I used AirTop by Transoft Solutions, and you can go to their website for more information on that.
Great. How much did your simulation leverage the ConOps and requirement derived from the NASA Vertiport Automation System project?
It didn't. We didn't develop it in coordination with them at all. We are familiar with the ConOps documents, however, and UML4 identified in the ConOps documents identifies the traffic levels for a busy vertiport, and it identifies 100 to 120 operations per hour as a busy vertiport, which is why I stopped my simulation at 5 FATOs. 5 arrival FATOs meets that demand.
Okay, and In your Joby planning slide, can you please restate how many daily passengers would be served?
Well, their tweet doesn't mention that, but they mentioned 10,000 trips per day. Again, if we assume a planning ratio of an average of 3 passengers per flight, that gives you 30,000.
What would the impact of low visibility be on capacity? I love that question.
So these systems are being designed to eventually be fully autonomous. So visibility becomes less of an issue with an autonomous system. Now, other weather characteristics like icing, wind, precipitation might prevent a flight, but it's unclear what the actual impact will be on low visibility, a fog situation, for example.
Okay, and last question here. Will you look at multi-level structures for phaetos or parking? Example, the second rendering you showed earlier in the presentation.
We would certainly look at them. We'll model them. We'll determine what the capacity is. Some people have even discussed multi-level parking structures that allow you to drop an aircraft down the side or elevator it down to another level for storage. So we can model whatever is proposed.
Great. Well, that concludes our Q&A. If you do have a question that has not been asked to Ken, again, please feel free to reach out to Ken directly using his email at ken@goskyway.com. That is ken@goskyway.com. Thank you so much for joining us today, and we look forward to seeing you on future webinars with Skyway. Have a wonderful day, everybody.